In this demonstration, we're going to look at designing a table named contacts and the data type choices that we have to make in designing this table. So the first field I want to add is first name. And we have to decide now which data type to use. We have a choice. We can use a car and have a fixed sized data type, or a variable car, var, have a variable length data type. Then if we choose, as we should, the var type, what is the maximum size that we want to set for that var? A quick internet search of first name length would suggest that the maximum length for a first name is about 11 characters. So we're going to choose to make our var 15. Give us a little padding above the 11. And then we're going to have last name, another field. Now this one, again, we can use a var for a variable length type. Or we can use a car, which is, again, a fixed length type. There's a recent story about a user whose last name did not fit into a database, and that last name was 35 characters in length. Therefore, to be safe, we're going to leave the last name at the default value of 45. We're going to use the variable character with a maximum length of 45. Next, we want to store a contact's email address. Our choices are fixed or variable length fields. In this case, 45 may not be enough depending on the email address. So we're going to up this to 50. Then we're going to store a phone number for our contact. Now the phone number is an interesting problem. If we assume, after discussions with the business analyst and the developers, we've agreed that the phone number will be 10 digits in length, an area code, a 3-digit prefix, and a 4-digit body number. So do we really want to use a variable length character in this case when we know that the phone number will always be 10 characters in length? I would argue no. And so we're going to change this to a car 10. Now, how about street address? This would include the numeric value for the street address, the street name, and whether it's a street, a drive, a circle, boulevard, and so on. So this storage location may need to be pretty well sized. On the other hand, it could be very small or null. So we don't want to waste space, and we will not use a fixed length type. We will use a var. We're going to increase the size to 100. How about city? Well, again, a simple internet search will reveal that the longest city name in the United States is 48 characters in length. And again, after discussions with the business analyst and the application developers, it's been agreed that the domain of our contact information will be restricted to the United States. So knowing that the maximum city name length is 48, we're going to use a var, but we're going to increase it to 50. So we're going to have a maximum size of 50 in our var storing the city name. How about state? We've discussed this with the business analyst and with the application developers, and we've all agreed that the state will use the standard post office 2-letter abbreviation for states. So do we need a var? Absolutely not. We know that the state data will be fixed length at 2. So we're going to change this to a car 2. We're going to add a zip code field. And again, after discussions with the business analyst and the developers, we've agreed that the zip code will always be 5 characters. Use the postal 5-digit zip code. So we're going to change this to a car 5. And we're going to have a switch for all of the records to identify whether or not the contact is active. So this is a yes or a no, a true or a false, a 0 or a 1. So what data type can we use that is the smallest, most efficient for storing either a 0 or a 1 or a true or a false? Well, let's look at our choices. We have a Boolean type. We have a bit type. Now this is where a fundamental understanding of the data types is important. A Boolean is really just a tiny int, which is 1 byte. However, a bit, which will store a value of 0 and 1, is more efficient. We're going to choose for a data type for our active switch in this table as a bit 1 field. We've decided to store a photo of the user in the table. Storing the actual photo in the database is not recommended. So we're going to do this just for this example. If we chose to store the actual photo in the database, which again is not recommended, then we would choose a blob data type for that storage. The more appropriate approach for storing the photo would be to store a path to the photo. So a string representing the path to the directory and the name of the photo within that directory that's associated with the contact, rather than storing the actual photo in the database. But again, to demonstrate the breadth of available data types, when we're designing a table, we're choosing to store the actual photo within the database. So here's our table now. This is a space-efficient design for the data types in the table. We're not using space we don't need to use. We've made selections between variable length and fixed length character types. And we want to add a date field to represent when the contact was added to the table. So we're going to call it insert date. Now again, there's different data types. We have date, date time, timestamp, time, and so on. So which one do we want to use? Do we really care that the insert date is anything more than a day? So a year, month, day representation. Do we need to know the time that the insert occurred? The difference being 3 bytes to store a date versus 8 bytes to store a date time. So we go back to the business analyst and to the developers and we have a discussion. Do we need the time, the exact time when this record was added to the table, or is the date sufficient? We come to an agreement that the date is sufficient, so we choose to use the date type. We have a very efficiently designed table with respects to the data storage types. Now, obviously, this table could be normalized. We haven't done that. This example is strictly about data types. So yes, we can further normalize this table, and one of the immediate normalizations would be to remove the state value into its own table, and instead of storing the actual state value, the 2-character state value, we could store a tiny int, a 1-byte value that represents the ID in the state table. There are only 50 states. We don't need a 4-byte integer to store 50 values. So we could use the tiny int, and that would save us 1 byte. The issue here isn't thinking small. The issue here is thinking that your database will grow to millions and potentially hundreds of millions of records. So when you're making the decision now to save 1 byte of storage for the state value in the future with 100 million records, you've saved 100 million bytes of data storage space. So these are the trade-offs that as a database designer we make in selecting data storage types for our variables. We have to be cognizant to use the space available to us in the most efficient manner possible. So we've seen the benefits of normalization of our database design. Remember that the primary function, your focus as a database designer, is to structure the data within the database in such a way as to allow fast retrieval of that data and to minimize data inconsistency within the database. Remember that your decisions during the design process have a profound impact on the future performance of the database. And making changes once you're in production to the structure of the tables within the database is painful and difficult. Our use of appropriate data types ensures the efficient utilization of the available storage for the database. And as we've seen, the MySQL Workbench tool is an excellent ER diagramming tool and provides, as we will see, the ability to single-click forward engineer our design into the database implementation.